Once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And today, and in this video, I want us to explain example 15 of Pure Mathematics 1 on page 127, whereby we are expected to sketch on separate set of axes the graph of y is equals to the graph of y is equal to sine 2x. And the reason why I've first of all constructed the graph of y is equals to sine x is because according to the Mayo, the magic square of transformation of graphs and waves and curves is talking about this is multiplication inside because x is affected because it has a coefficient of 2. Multiplication outside means multiplication inside rather means there is horizontal stretch of scale factor 1/2. This is horizontal stretch of scale factor 1/a, and you can see our a was a 2. That means 1/2, horizontal stretch of 1/a, which means that since it is horizontal, all x values multiply by a half. Y values are not affected. So what does that really mean? And allow me to just sketch this in this axis so that we can see it clearly. So when theta was 0, rather x was 0, y was also 0 here, and x, which is 0 times a half, remains 0. But when x was 90, y was 1, and x being 90 times a half is going to be 45 degrees, but the y doesn't change. We are going to talk about x being 180 degrees. X times a half is going to be 90. Y was 0, 0, y doesn't change. At this particular point, x was 270. 270 times a half is going to be 135, and at that particular point y still continues to be -1, so this is 135, and y doesn't really change. When x was 360, we're going to talk about y being equals to 0, and x being 360 times a half is going to be 180. Y doesn't change for that matter. Of course, it goes without saying that when x is now going, if we add 90 here, is going to be 240 degrees. And the sine, let's talk about the sine of 450 degrees. The sine of 450 degrees is going to be 1. Now 450 divided by 2 is 225, and 225 is going to be around here. This is 225. Y doesn't change, it still continues to be 1. 450 plus 90 is 540. The sine of 540 is going to be 0. 540 divided by 2 is 270, and the y doesn't change at all. Of course, it goes without saying that the sine of 720, the sine of 720 degrees is 0, and 720 divided by 2 is going to be 360, so that y doesn't change. Now, it goes without saying that between 270 and 360, we're going to have 270 plus 45 degrees, which is 315 degrees. If you multiply this by 2, you're going to get 630. And the sine of 630 is supposed to be -1. So 630 divided by 2, we have 315, but the value of y does not practically change. So we have a curve that behaves like this. The red graph now is the graph of y is equals to the sine of 2x. You can see we have had a horizontal stretch of scale factor a half. Every value of x is divided by 2, and we can see that the graph of y is equal to sine x is stretched horizontally with scale factor equals to a half. You can see the period is now 180 degrees, for example. When we talk about one period, is just when we have a complete circle from here, go down, go back there. It's simply 180. This line is supposed to pass there 180 degrees. The red line, this is not correct. This is the graph which is correct, 180 degrees. And of course, that is the way. So at the end of the day, you realize that there are two complete periods that are seen within the range of 0 and 360. Now, this is one period, this is another period, so two complete periods. That is it. If we may wish now to explain part B in the same kind of video, I choose not to do that because the video is going to be so long, but at the end of the day, we will see it in the next video. So again, go to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Subscribe and of course share widely, and let us meet in the next video when we shall be explaining part B, which is y is equals to the cosine of theta over 3 all the way from 540 degrees to positive 540 degrees. Be on the lookout for this explanation and transformation. Otherwise, for now, that is it. Please follow me and let us walk this journey together.